Oh, okay, let's begin. Thanks for joining all. We are going to kick off the final learning unit today, this evening. So the final learning unit is chi-squared distributions. So let me give you some kind of insight on what that's all about. So one of the applications which we're gonna cover this evening is, let's say you wanted to test a theory, and the theory that you want to test is the proportion of people that surf in Durban, is it the same as the proportion that surf in the Eastern Cape, which is also the same as Western Cape? So if you wanted to look at the proportion of people that surf in those three provinces, then that's where you would use a chi-square test. So that's just in one example, but you can think of other examples. Wherever you want to test the proportion of something, across maybe different locations, or maybe even within a certain vicinity, but just different groups, then that's where you would use a chi-square distribution. And another application is if you want to test whether two variables are independent. And what do we mean by independent? Okay, so let's say one of the variables was whether it is the amount of rain in Durban, and the other variable is the gold price on the JSE, right? Now, intuitively, the amount of rainfall in Durban wouldn't really have an effect on the gold price. There's no kind of reason to see any sort of relationship between the two. So that means what I'm saying is, if it rained a lot heavier next month than this month, I don't expect that to either cause the price of gold to increase or decrease. Now, that's what I mean by independent variables. But then you can have variables that are dependent, or that there is an association. And for instance, one variable could be the amount of hours you spend studying, and the other variable is your score in the exam. So as you would expect, the more hours you can contribute to studying, you would expect your exam mark to be higher. So that's an example of variables that are associated. And so what the chi-square test does is it confirms that these variables are independent or they're not. So that's what we call the test of independence. All right. So let me share my screen, and I'll take you through an example to put this in perspective, and I'll show you how to actually do this test. All right, so I'm just going to share my screen, and if you can't see it, please let me know. Okay, so on the right, and if you can't see the writing, if it's not clear, please let me know, okay? Um, I want you to be able to read what's on the text on the right here. So it says an advertising agency conducted a survey across three provinces, which is the Eastern Cape, Western Cape, and KZN. And they did this in order to determine the proportion of readers that read a particular sports magazine. So what they did was they surveyed 300 readers, and the results are shown in this table below. So what you see in the first column is, you'd see no and yes, and the no means that the readers don't read the sports magazine, and yes means they do. So in the Eastern Cape, we have 100 of them. Of that 100, 84 do not read it, and 16 do read it. And the same thing for Western Cape. We've got 86 that, excuse me, we've got 86 that don't, and 10 that do. And in KZN, we have 26 that do, and 78 that don't read the sports magazine. All right, so that's what this table tells us. So the first question asks, test whether the advertising agency can assume equal proportions of readership of the sports magazine across all provinces. All right. So just ignore the 1% level of significance. We'll come to that in a second. So I'm just going to draw your attention to question 1 only. All right. So let's start walking through this problem. And if you can't see my whiteboard, please let me know on the left. So question 1, what they want us to test, okay? So question 1, we are testing for equal proportions across the three provinces. So what I'm going to do is, for proportions, the symbol is pi, okay? I'm going to put a subscript here, E for Eastern Cape, right? So I'm going to say pi Eastern Cape. And then I'm going to say pi for Western Cape. So I'm going to put a W here, and pi for KZN. Now you could replace E, W, and K with 1, 2, and 3, right? There's no problem in doing that. You can absolutely do that. But I'm putting this just so I can refer to it better. Now what they want us to test for question 1 is test whether these are all equal. That's what they're asking us to test. So that's your H naught. Okay, H naught is that the proportions are equal. Now, if that's H naught, and so far when we've been working with hypothesis testing, we've always found that just doing the opposite of H naught is H1. Okay, so you would be tempted to say pi E not equals to pi W not equals to pi K. Okay, you'd be tempted to do that, but don't do that, because that isn't exactly what H1 is. For H1, we only care that one of them differs. So what I mean by that is I could have pi E equals to pi W, but pi W and pi E is not equal to the proportion in KZN. Or I could have these two equals and this not equally. That's good enough. So that's what H1 is. So in other words, I don't really have to write mathematically what H1 is. All you need to do, you can write this in words, is that at least one differs. That's what you say. So that's what you would write for H1. Okay, so that is our null hypothesis. We've stated our H naught and H1. So for this problem, for question 1, this is your step 1. Okay, so what we've just done now, this is step 1. All right, now, step 2 for hypothesis testing, just like before, we find the acceptance and rejection region. Okay, now to do this, it's a bit of a different process from what we've been doing in the last 2 weeks. All right, we are going to use something called the chi-square table. All right, and this is where this level of significance comes in. In the question, it says use a 1% level of significance, right? So in other words, our alpha, that's your level of significance, is 0.01. Now, as I said, we are going to be using the chi-square distribution. So in the back of your book, I'm just going to draw your attention to this diagram. Forget everything on the left side, just look at this diagram. This table is in the back of your book, all right? Table 3. So we've done table 1, which is the normal distribution or the Z variable. Then we've done the T distribution, which is table 2. And table 3 is the chi-square distribution, right? You'll find this table in the back of your book. So what we're doing is we are going to use this distribution to determine the rejection region. So I'm going to sketch this exact same curve here. All right, so I'm going to sketch it. It doesn't have to be accurate. So it's skewed. What I mean is it drags out on the right. Okay, it's not a bell-shaped curve. And for the chi-squared distribution of the chi-square test, your rejection region will always be on the right. So you don't really need to say whether it's a one-tail test or two-tail test. Your rejection region will always be on the right, like this, okay? And the size of the shaded region that I have, that's what your alpha is. So the size of that shaded region is 0.01. That's what your level of significance is. Now, the trick here is to figure out what is the value on the horizontal axis that corresponds to an area of 1%. Now, how you determine that is if you look at this table, right? This image of this graph, you have on the first row all your different alphas. Now, we are dealing with alpha equals to 0.01. So we would be using this fourth column, right, where we see 0.01 here. on the first row. So that's the column we're going to use, but we just need to figure out which row do we use, okay? And how do we figure that out is we have to work out something called the degrees of freedom. So if you look on the left, on the first column, you'll see df there. That df is your degrees of freedom, right? Now, how you work out your degrees of freedom, we're going to use a formula, and I'll explain it in a second, so don't panic. It's in brackets r minus 1, close brackets, times c minus 1 in brackets. Now, all that r and the c is just your number of rows. So your r is how many rows do you have, number of rows, and your c would be the number of columns. Now that you can work out from your table. If you look at the table that they give you in the question, how many rows do you have? You have a row for no, and you have a row for yes. So there's only 2 rows. So in other words, your R is 2. And your columns, well, you have 3 columns. You have a column for each province. So it's Eastern Cape, Western Cape, and KZN. So that's why your C is 3. So if you substitute your R and C into this equation, you're going to get 2 minus 1 times 3 minus 1. All right, and that gives you 2. So your degrees of freedom is 2. Remember to do your brackets first and then multiply them out. Okay, so your degrees of freedom is 2. So now if we go back to our table, all right, now you don't remember this table is given to you in your exam, okay? So, you don't have to memorize this. So now remember what we said, your alpha is 1%, so it's that column where alpha is 0.01, and your df, which we just worked out, is 2. So in other words, there's 2 for your df, which is here. Let's take it across, and where it intersects the column where alpha is 0.01, you'll see that your value here is 9.21. So that's the value on our horizontal axis. That's your chi-squared critical value. So in other words, everything from here onwards is going to be rejecting H naught, and everything before it, we will accept H naught. Okay, now that's your step 2. Okay, everyone following? Let me check the chat. Okay, please let me know if there's any questions, all right? Okay, so that's your step 2. Now, I know I told you previously for hypothesis testing that the bulk of your, the work is done in step 2. All right, now that is true for all hypothesis testing, except for the chi-square test. For the chi-square test, your step 3 is going to take up most of your time, right? So it's a very systematic approach. It's not too complicated, but it's a lot of work, all right? But you are awarded quite a lot of marks for the step. So take note of this, and if you're not sure about anything, please ask away. All right, so now we're going to do step 3. All right. Now, step 3, what we need to do here is to work out our test statistic. So we need to calculate our test statistic. In other words, your chi-squared test value. That's what we need to work out. Now, the formula for this is given to you. So I'm going to write it out, but don't panic about it. It is in your formula sheets. You don't need to memorize this. You just need to know how to work it out. So the formula for it is sum F naught minus FE all over FE all squared. Okay, that's your chi-squared statistic. All right, now, if you don't want to memorize this formula, that's fine. It's perfectly fine. Just follow the steps that I'm going to show you how to work this out. Okay, so I'm just going to move this to the right. Oops, sorry. Second. I meant to move my Excel across. All right. Okay, so what we're going to do is, in that formula, there's an F0 and an FE. What I want to work out is my FE values. Now, if you look at the question, everything that's given to you, so what I mean is all those numbers in the table, those are your F0 values. Okay, those are all your different F0 values. I need to work out what are the corresponding FE. FE means the expected frequency. F0 is the observed frequency. So the observed frequency is the observed values that's given to you. Now the expected frequencies is something you need to calculate. All right. So what I'll do is I'm going to sketch a different a table with the same format. So I got no and I got yes here. Okay. And then I got my three provinces on the top: the Eastern Cape, Western Cape, and KZN. All right. So it's the same format, but instead in this table, I'm going to populate it with my FE values, my expected frequency values. Now the formula to get your FE, now this formula you need to memorize, okay? It's not given to you. So the formula you're going to use is row total times column total all over grand total. All right, this formula you need to memorize. This is how you work out your FE values. All right, I'll explain to you how to use it. It's very simple of how to use it, but you just need to memorize it. Okay. In this formula, you got row total, you got column total, and you got the grand total. So all that means is if you look on your right, okay, in this table on the right, there you can get your row totals and your column totals. So in other words, what the table is given to you, right? You got no, you got yes, right? You got Eastern Cape, Western Cape, and you got KZN. All right. Now, if you add up the values going down, so for instance, look at Eastern Cape. If you add up the 84 and 16, you're going to get 100. Same thing with Western Cape. If you add up the 86 and the 10, you'll get 96. All right, and then lastly, for KZN, you'll get 104. Right? Now, if you add up the values going horizontally, you're also going to get a total here. So if you look at it, what I mean is, look at just everyone that doesn't read this magazine. So in other words, everyone that falls in the row where it says no. So that means you've got 84, 86, and 78. So if you add those three up, you're going to get 248 here. And the same thing if you add up all the values for yes. Okay, if you add up all of that, you're going to get 52. And if you add everything, every single value in this table all together, add them all up, you would have 300. So that's your grand total. This 300, this is your grand total. All right. And so the values that you have here, this is your column total. And here, this is your row total. This is your row total. So to use this formula here, you just use these totals that we just calculated. So let's look at the first value, right? I'm going to populate this value here. All right. For no and Eastern Cape. So if we look at this position in the table, the row total, if you look at this equation, the row total is 248 because the total is here. Remember, 248 and 52. And the column total here is, I'll just write it out again, 100, 96, and 104. So for the first position, its corresponding row total is 248. So 248 times what is its corresponding column total? It's 100 divided by the grand total, which is 300. And if you work that out, you get a value of 82.67. So that is its FE value, 82.67. Okay, so let's do the next one, all right? For Western Cape and no. We're going to use the same formula, row total times column total over grand total. So here its row total is 248, so 248 times its column total, which is 96, all over the grand total, which is 300. And if you work that out, you get a value of 79.36. 79.36. Okay, so just to check that you're following, okay? If you understand how to use this formula for each one, can you work this one out here for me, what I'm circling? What is that value? Using this formula here. Row total times column total over grand total. Okay, work it out and put the answer in the chat. I just need to see that you're understanding how to work out the FE values. So remember, it's row total times column total over grand total. Good, people are trying. All right, good. Nice. Well done, everyone. That's right. It's 18.03. Very good. Very good. Okay, so you understand it. So you just follow that process for all of it. So I'll write out all the values here. It's 85.97 and then 17.33 and 16.64. All right. So this whole table that we just did, that's your FE values. You found all the FE values. All right. Okay. So now that we've done that, okay, all I'm going to do now is I'm just going to rearrange this table. So I'm just going to make some space here. I'm going to remove this. Okay. Now, if you look at what's given to us, right? This table that's given to us, I'm just going to rearrange it. Okay, I'm going to change the order and the structure of it. Okay, but I'm not really changing the values. So what I mean by that is what I'm going to do is I'm going to create the value no, right? And all the provinces that fall under no. So in other words, we have Eastern Cape, we have Western Cape, and we have KZN. Right, and the corresponding values from the table that's given to us. Right, if you look at the table that's given to us, it says for Eastern Cape, there's 84 that I know. Okay, so it's 84. For Western Cape, it's 86. And for KZN, it's 78. Okay, now I'm going to do the same thing for all the yes values. For everything that's yes, it also has 3 provinces, which is Eastern Cape, Western Cape, and KZN. And the first value for yes, for Eastern Cape, it's 16. Then it's 10 and 26. All right, that's all your F0 values. And then what I'm going to do is I'm going to write my corresponding FE values, which we just worked out. We did all the work, we've got the FE. I'm just going to write it in a column next to it. So here it's 82.67 for the first one. For the next one, it's 79.36. Then 85.97. Okay, almost there. 17.33. 16.64. And lastly, 18.03, which you worked out. All right, so we got these values side by side. All right, there's a reason why we're doing this. Okay, I know it seems like a boring process, but I'm writing it out like this because it's going to make the calculation a lot easier. All right, so now that I've written the values there, I don't need this table anymore. Almost there. Okay. Now, earlier I told you that the formula for the chi-squared test, chi-squared test statistic, is sum f naught minus fe all squared divided by fe. Okay. Sorry, the sum is for everything. All right, so, and I did say you don't need to memorize this, and you don't need to worry about this formula. If you just follow what I'm doing in this table, it's going to take you to this formula, this value anyway. So the next column I'm going to create is I'm going to create a column that calculates the difference between these two columns. So it's going to be f naught minus fe. All right, and I'm going to square it. So it takes the difference and I'm going to raise it to the power 2. So in other words, let's look at the first value, right? The first value that I'm going to calculate here. I'm going to take the corresponding f naught value, which is 84. So it's 84. And I'm going to subtract its corresponding fe value, which is here, right? Which is 82.67. I'm going to put it in brackets and I'm going to raise it to the power 2. That's what I'm going to do in my calculator. Now, if you do that, you'll get a value of 1.78. All right, so that's the first row. Okay, the next row is exactly the same thing, except the values are just different. Okay, so the next row is going to be the f naught value is 86, and the fe value is 79.36. Okay, I place it in brackets, I square it, and then I'll get the value. So that value will be 44.09. Okay, so you get the idea. I'm going to do that for everything going all the way down. So the next one will be 63.57. Please just let me know if you're not following, if there's anything that's not clear. And maybe 1.78. And 44.09. And 63.57. Okay. All right. So now we've got our column of these values. All right. Now let's draw a line now and create another column. Okay. For the next column, I'm just going to take everything that I have here and I'm just going to divide it by FE. So in other words, everything that I have in the column before, which is just this, divided by FE. So in other words, I'll show you exactly what I mean by this. Okay, let's look at the first row. What I'm going to do is I'm going to take the value in the column before, so the 1.78, and I'm going to divide it by its FE value, which is this column here. So the corresponding FE is 82.67. So it's divided by 82.67. All right, when you do that, that's the value I'm getting here, because that's what this formula is telling me to do. Take everything in the column before, which is the numerator, and divide it by FE. And if you do that, you get a value of 0.022. Okay, you're going to do that for each row. Okay, so for the next one, it's going to be 44.09 divided by 79.36. So I'm going to do this for all of them. Okay, now instead of me writing, I'm just going to show you the working, which I've done already. Okay, so here, I'll draw your attention to this table here. That's what I'm doing. This is the last column. Okay, so all of these values is following the step I just showed you. Okay, now you do that for each of them, and then the last thing you need to do is add all of these values up. So in other words, if I add up, after you do all the workings and you add up all these values, add them all up, you'll get a total on the bottom. That total is what you need, 7.595. Now this is your test statistic. All this work that you've done was to work this formula out. That's what you've done. Okay, this is your chi-squared test statistic. And I did tell you this step is the most amount of work, and now you see why. All right, it is a lot of work, but you do get marked for it, but it's very important that you understand this. Okay, so this is your chi-squared test statistic. And now what you do with this test statistic is you look at where it falls in your rejection or acceptance region. Now, if you look at the value you got a value of 7 point, let's say 7.6. Okay, we'll round it to 2 decimals. Sorry, to 1 decimal, 7.6. Does 7.6 fall before 9.21 on the left, or does it fall on the right of 9.21? Now, 7.6 is smaller than 9.21, so that means it falls here. So that means it falls in the acceptance region. So that means we accept H0. Okay, we accept H0. So this is true. And we've pretty much answered how our hypothesis test. Because if we are accepting H0, we're saying that the proportions are equal. So in other words, each province has the same proportion of readers for sports, for the sports magazine. All right, all of this work was to answer that. So in other words, if I had to write this out, okay, I'm just gonna create some space here. One second. Okay, so your final step, okay, sorry. So step 4, we already just answered it. Okay, we accept H0 because it falls here. So that's accept H0. Step 5 is the final step. And that is to just write it in words. Okay, so if you recall from last week, I emphasized that you should start off with your level of significance. So you would say at a 1% level of significance, at a 1% level of significance, right? We accept H0, or you can say do not reject H0. Both are fine. We accept H0 and conclude that the proportion of readers are the same across all provinces, are the same across the regions. This is how you'd answer this question, okay, for your final step. Okay, just make sure everyone understands that. Okay, so step 3 is a lot of work, but that calculation gives you your test statistic, which you need to use to figure out whether you're accepting H0 or you're rejecting it. Okay, and then step 4 and 5, it's just interpreting your result. Any questions? Okay, so far so good. All right. Okay, so what you did, all of this work, this was a test of equal proportions. Okay, because as you can see for your H naught, you're testing whether the proportions are equal across the different provinces, right? So this is the chi-square test of equal proportions. The other chi-square test you can have is the test of association. So as I mentioned earlier, when you're testing whether variables are independent, like the example I gave you with rainfall in Durban and the price of gold in the JSE, all right? You can also get asked to test whether two variables are independent. So in this example, for this exact same problem, we can get question 2, which is on the right. So question 2, so it's the same data, but instead we're being asked to test whether there is an association between readership and province. So in other words, they're asking us to test whether the variable represented by the rows is associated with the variable represented by columns. So it means, what it's basically telling you is, does being in a certain province increase your chances of being a follower of this magazine or a reader of this magazine? So in other words, are people in KZN more likely to read this magazine? Does where you live influence whether you would read this magazine or not? That's what a test of association is. Okay, it's asking you to see whether your region actually influences whether you read this magazine or not. So if you asked this, like say you were given question 2, everything that you did in question 1 is pretty much the same. So all the workings, the calculations, this diagram with the rejection region, it's the same. The only thing that changes is your step 1, okay, is your step 1, which I'm going to erase here, and your last step. So your step 1 is what exactly is your H naught and your H1, and your step 5 is going to be different, but everything else is exactly the same. Okay, so let me just erase this and I'll show you what I mean. So before, our H naught and H1 was the proportions being equal. In other words, your pi 1 equals to pi 2 equals to pi 3. Okay, but now what you're testing is what you're going to state in words, not mathematically. So what you're testing for H naught is that region, or you can say provinces if you want. I'm going to put region, and readership is independent. Okay. Now instead of writing it this way, you can also say region and readership is not associated. Both are acceptable. Okay. Just remember that. You can either write it like how I wrote it, that they are independent, or you can say there's no association between region and readership. It's the same thing. And your H1 is the opposite. So here you can say there is an association between readership and region. Readership. Okay. So now you can see your step 1 is different. It's just how you phrase your H naught and H1, right? So that's the difference now with question 1 and question 2. It's a different test, but all the maths behind it is the same. So like I said, step 2 is the same. Region is still the same, your rejection region. Step 3, all this calculation, all of this work that you've done here, it's the same. Step 4 is the same. You accept H naught because the test statistic has not changed. Now, step 5 is going to be different because your H naught is not testing whether proportions are equal. Here, you're accepting H naught, so that means you're accepting this. So all that means is that from the result of this test, it means region and readership is independent because you're accepting H naught. So your conclusion is just different. All right. So in other words, you would say it the same way at a 1% level of significance. Okay. We accept H naught and conclude that readership and region are independent. Region are independent. And that's it. That's question 2. So they're the same tests, okay? So your takeaway here, right? So I'm just going to maybe go to a new page. For the chi-square test, all right? There are 3 tests that you can get asked at the chi-square test. Right, there's 3. There's the test of equal proportions. So that's what we did first. That's your pi 1 equals to pi 2 equals to pi 3, etc. All right. Then there's the test of association or independence, which we did right now. Right now, these two, they're very similar. Okay, the maths is similar. The maths is the same. Math is the same as you saw. Okay, it's just your step 1 and step 5 that are different. All right. And then there's one more test, but we're not going to do that this evening, but I'm just going to make you aware of it. We're going to do that in the next lesson, and then we're done. All right. The last test is your goodness of fit test. And that's a bit different, but that's why I'm leaving it for another session. Goodness of fit test. All right. So that we'll do next week. Okay. Everyone. Any questions? Do you understand that? Is there anything that you weren't sure about that you would like me to explain again? So this is the chi-square test. Yeah, it carries from all the questions, this would carry the most amount of marks, like per question. And you can see why, right? There's a lot of working that needs to be done in step 3 of the hypothesis test. You know, getting your FE values, then arranging the table, and then doing those last bit of calculations. I mean, just that step alone could probably give you like about 5 marks, just that one step. So in total, a chi-square test could give you nothing less than, I'd say 10 marks, okay? So that's why I know it's a lot of working, but it is heavily weighted in terms of marks if you are doing this question. All right, so we've done the chi-square test, we've done it for equal proportions, and we've done it for independence. We just have one more to do, and that's going to be next week, and that's the goodness of fit test. Okay. Floor is yours if you want to ask any questions. Otherwise, you know, you're welcome to drop off, everyone. But thanks for joining.